ING90 week round 2. Thanks everybody for coming back and making it back in the room the second time. I've sent around the roll, so you do need to tick off the roll, but I just want to make sure that I've got a member of each group in the room. We'll do that in a minute, because an important part of today's lecture is going through these brief project reports, just so that everybody in the class knows what everybody else is doing, and we can sort of share our experience a little bit more about doing these research projects. So just to start off with, Yim would like to just go through a few things with you, which I'll present from my laptop, and you can explain as you go. Okay, well, we'll grab this next slide. So, I've welcomed you back. The next thing we're going to talk about is this kind of feedback concept. So you guys filled in some preliminary feedback forms, which we've gone through and made a few changes to the way we're running this course in response. The first change is obvious that we're in a different room. I think that was quite clear from the feedback and our experience up in the Robin Pause area that wasn't ideal for running a course with this many students. And now we're trying to make sure that we get as many lectures as possible in a much nicer space. It's a little bit difficult to do that all the time when we run these intensive courses, because particularly on Wednesdays, this building is very busy and actually every room is used on Wednesday afternoon. So I think on Wednesday afternoon we'll have to have the lecture in the Robin Pause area unless we find out some emergency space that's available then, which might still happen. But today it's in this room C, tomorrow it should be in Postscript, Wednesday in the Robin Pause area on level 4. Thursday it will be in Shell downstairs, and then on Friday we'll have a short session back in this room. So we should be a lot more comfortable and have a bigger screen, and it'll just be a nicer experience for everybody. So I'm just going to bring up the some feedback from these course sort of questionnaires. I'll zoom in on each of these slides. So this was, I guess we got around 25 responses, so that's almost everybody responded to this little survey. So what is your general impression of the course so far? 20 people said, very good. I say that that's pretty good. Thanks everybody for showing up. Hopefully your opinion of the course continues to be very good through this next session, but as always, if you've got any concerns or think that things are going a bit off the rails, either in your own project or with what we're doing to teach you and lead those projects, then please get in touch with us. What do you think of the course's difficulty level? Almost everyone said appropriate, which is appropriate. So hopefully the course continues to be appropriately difficult. I suppose that's the best you can hope for, right, Jim? Not too easy and not too difficult. I guess this is a different kind of course than a lot of computing courses you might do, which would have quite set kind of technical accomplishments that everyone in the class has to do, and set obliques or assignments and a set exam. In this course, everyone is sort of going in different directions. So some people might have chosen something which is extremely technically challenging. Some people might have chosen something which is not quite as technically challenging. The thing that everyone has to do in this course is get through this process of explaining research to someone else, writing their project report, and doing little presentations of research through reading papers as well as their own research that they're doing in their project groups. So it sometimes can be a bit hard to gauge how difficult that is, but I think that that's something that when you zoom out, you think, oh, actually, that is quite difficult, and maybe if you haven't done it before, it might feel a little bit quite difficult to get to the first stage with that. But I think overall, the difficulty level has been appropriate so far. What do you think of the amount of work required in relation to the number of credits given? Again, most people said appropriate, and then some people said large. I suppose, given that this questionnaire was in the first intensive week, maybe not everyone has a clear idea about what the work level was going to be over the whole semester. And so perhaps the people who said don't know were the ones who are the most honest here, because it would be hard to gauge what the work level is going to be throughout the entire semester, but I think hopefully the work level continues to be appropriate, but we'll see at the end of this week what everyone is thinking. So I don't know, does anyone want to raise any issues related to these feedbacks or bring up anything right now at the start before we get started? Anyone yet to sign on to the role? No. Okay. Right. So that's the feedback session. Also, there was some written feedback which many of you chose to write down for us, which was very useful. We read all of those comments and thought about those. Not all of that feedback is. Oh, do you have a question? Thought?
Yeah, just remark or some feedback.
Yes.
I think me and several others experienced it as a little overwhelming when we were to deliver our first draft of the paper.
Yeah.
Because we had not so much to go on to make the draft. And yeah, it was a little.
Yeah. Does anyone else felt a bit overwhelmed about that first draft? Yeah, there's some nodding heads.
Yeah.
So you're not alone there.
I would think that having mandatory assignment or something, not a general one, or a general one, that is not one specific, but like some delivery that everyone has to do.
Yeah.
So we like set a date, and everyone has to make such and such much progress on their project, technically, and have such and such data sets to go out from before they actually write the draft.
Yeah.
So to make sure that everyone has something to write about.
Yeah. Okay.
If not, we are just sitting there and we have to make a draft, and we're like, oh, okay.
Okay, I take your point. It's difficult to work out what to get into that draft. I think that's probably something that we'll work on going forward. Do you have a thought about that?
No, I think that is definitely it's important feedback. So at the same time, we see that our semesters our semester is rather short. So and we are eager that all of you should end up with a good paper. Like in a similar way as you are doing research for your master thesis coming up. So then you saw that someone had to jump into deep water in the beginning and just to get started, and we didn't expect to have any finished paper this time here. So it was more to push you into the process of starting writing. So yes, I mean, nobody will fail, but for at this step here. But it was more that. We have this intensive week, and we just have another week in November. So it's important for us that we also in this week are able to give you feedback on your on not only the experiment or project, but also on how you prepared this paper. But I can see that we push you a little bit early there, but. We had a good intention when doing it, but then we're happy to hear how it turns out.
I'm happy to hear that you were challenged to do that, right? That's my idea with that assignment was to make sure that everyone in the class was challenged to have to write down something, even when you don't have all the answers, and that can be really tough to do. But I think maybe we could improve the communication next time on what the expectations are for that early draft, so that maybe it's a bit more clear that yes, you can accomplish this even before you've got your experiments done, or even before your data set's fully in place. So I think that's something that will come with experience with this course. And so the comment is really useful, but I'm looking forward to hearing about what you've achieved so far later today. Any other comments about the feedback? No? Okay. I'm going to close this. Let's go to this one. So, first of all, we've got project reports. So the project reports start this afternoon. Where's my project reports tab? Now. So the project reports, there's 9 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9. Has any group not sent their project report to Enrico? That slides. You haven't? So we've got 2 groups that haven't. And I've got this gift prepared. Shame, but there's still time. You can still send it to Enrica. I trust that you've gotten the emails. I sent out a reminder email that had Enrica's address. The reason to send it to Enrica is that I just wanted to have all of the slides and all of the papers on one computer so that Enrica can be sort of in control of that session. Then the way that will work, I guess, is that Enrica will have to bring up these presentations one by one. You and your group will come up and present about the project. There's a few questions or loose sort of questions that would be good to hear from you about your project in that session. What's the main objective? What's the method? What's the training data, if that's relevant? And what experiments have you done? And then a little bit more of a general question about your overall experiences. Yeah?
Is it possible to make it a little larger? It's a little hard to see from
Right.
the back. All right, great.
Wow. Okay.
Yes.
What's the main objective? What's the method? What's the training data? What experiments training have you done? How has your overall experience with it been so far? So that's just a general idea of the kind of questions we'd like you to answer. I think everyone gets 8 minutes, 8 to 10 minutes, because we've got 9 groups to get through. That means like 90 minutes. If we have 0 minutes changeover, of course, there's always at least 1 minute changeover. So it's going to be pretty heavy going through that session. Hopefully everyone stays for the whole thing. I'd really like it if you heard what everybody else in the class was doing so that you had a great overview of how much people have gone. That means that if your group, maybe you haven't had enough progress, you can see other people and be a bit inspired to, you know, get your skates on. And maybe if you have done a lot in your group, you can see other groups and think, oh, I can actually take a breather here and maybe work more on my writing and make sure that everything is clear. And that might sort of alleviate some stress both ways so that the expectations are clear. Yes, final point?
Yeah, and you may add also that our supervisor in Brazil, he will be joining us.
Yes.
So we will start out with those projects that are supervised by Bruno in Brazil, and he will be joining us as electronically.
Yeah, we heard today that some members of the class thought, we're under the impression that Bruno worked at IFI, but he does not. He works in Brazil. So he was just here last time giving these fantastic lectures as a visiting researcher, and this time he's still joining us. He's still supervising groups, but he's coming via Skype from Brazil to hear it. Now, just a little bit of further information for the rest of the week. I'm just going to bring up the schedule. So, today I'm going to give a little lecture, then we've got project reports for the rest of the afternoon. Tomorrow Zia is going to give 2 lectures based on feature extraction, Zia from the Robin Group. And then at 4:15 tomorrow we're starting our papers presentations. So each of you will have prepared or be preparing possibly a presentation of a research paper from the literature, and you'll have to present that for 8 minutes. The schedule for those papers presentations I emailed to everyone. I should put it on the website so it's clear, but it is actually right here. So these are the 13 students who have their papers presentations. So me, you have to go first thing on tomorrow at 4:15. Someone has to be first. Farzan second, Sebastian third, and Nikolai. You guys are all on Tuesday afternoon. The tricky one is going to be on Thursday because I've scheduled 5 students for the Thursday afternoon, so we might go a little bit late, or potentially, if we don't get through everyone, move someone to Friday if they're available. But we're trying to make sure that everyone has sufficient time to explain their paper that they're going through. If you have any questions about that, we're happy to talk about it a little bit later. Just going back to the schedule before we stop. On Wednesday, we've got 2 lectures from Renan in Brazil. So Renan is one of Bruno's colleagues in Brazil, and he's going to join us via Skype or video conferencing to present remotely. So that will be interesting. That's obviously some challenges in making sure remote presentations work, but we will try to manage that as best we can, and as always, your feedback is appreciated and interesting to us to help improve that process. But I think it's quite exciting that we're able to access a really international group of top teachers and researchers to help bring this course together. Thursday we've got Renan as well, and then on Friday I've booked this room from 2 o'clock until 4 o'clock, just in case we need extra times for extra presentations, or if anyone wants to come and discuss their group work so far, I'll be here during that time to help with discussions. In the afternoon classes, we've got pizza today. Yay! No food tomorrow. Ooh. We've also got pizza on Wednesday. Yay! And then we've got sandwiches on Thursday. Yay! So that is the food situation. Now, any other thoughts?
Any questions? Are you having any questions? As everything is clear for the coming week. We just hope that that most of you were able to come, and it seems like most of you are actually here. So, we interpret that as having this session from 2 until 6 is the best possible compromise as it looks now. But unless any of you are urgent in telling us anything else.
Okay, not hearing any more thoughts. I'm just going to get on with the lecture in a minute, but before I do that, just the first groups up after the break will be Bruno's groups. So that's the pen group, the auto encoders group, the job group, and the stunning auto encoders group. So you guys are all kind of like ready, right? If you're not ready, make sure you are by the time we get past the break. Another final thing. Oh yes. So it's been this intensive week. There's a lot of questions, right? And sometimes it's hard to get through all the questions in the lectures. So I thought we could try this thing called Slido, which is a way of like having asynchronous question asking. So if you go to slido.com and enter this little code, then what you can actually do is, I'll just see if I can do the normal view, slido.com. D303, that's my group. So you can start asking a question, right? And you just, why don't we pizza every day, right? You don't have to put your name in, but that works. How does this work? Someone was already asked. And if you see a question that you also have, maybe you can also like that question. So the questions that are often liked will go to the top. And then what I can do is come back and put the question screen up. So that might be actually pretty helpful for the lectures with Renan coming from Brazil, because that way we can take a bunch of questions which might be a bit difficult to manage through Skype, and then we can sort of pin him down for a question answering part of the lecture as we go. So I'll just write this on the screen. That's slido.com. And the room code is D303. Cool, so this is a bit experimental, but it might work. Oh, someone says perfect, so cool. So now we get to the serious business. Mixed density networks. Okay, so time for my first lecture.
So camera angle is like that.
It's like that? Okay.
If you would like to be in the picture, at least once in a while you have to go to the front.
Across the screen. See, hopefully someone has been looked at the videos, because Farzan put a lot of effort into making them. So thanks, Farzan. Putting the videos on the website. It's great to have videos of lectures so that we all know what happened. So now I'm going to talk about mixed density networks. So this is a topic which will be probably a bit of a mystery to most in the class. Some more than others. Hopefully it's less of a mystery to those students who I'm supervising who are working on mixed density networks, but possibly it's still a mystery to them too, so we'll find out. We're all working together. This is one of these things which is like a true research topic. There's no like textbook on deep learning that talks about mixed density networks. Well, actually the deep learning book does in very brief. It's got a very short section on them. But there's something which are maybe unpopular, but exciting. So they're an interesting idea, and so that's why I wanted to talk about it in this class. It's an exploration of an interesting idea that could be useful in research in the future. Hopefully it is, because I've been putting a lot of work into it, but it's not that common. So you'll have to bear with me when we discuss this, because the academic community is still working out the best way to talk about many of these uncommon topics in deep learning that we haven't quite figured out yet. So far in this course, in my last lectures when I was talking about RNNs, I was talking about neural networks that model categorical data. So you can see that there's this, these RNNs had these outputs as a kind of probability distribution across different letters if they were text generating neural networks, right? And they did this by having a softmax layer at the end of their the neural network. The softmax layer was outputting this probability distribution of categorical predictions. Okay, so the softmax layer is a mathematical operation that can take a list of numbers and change that list of numbers, which might be sort of abstract weights, relative weights, to a list of numbers that sum to 1. So they make up a discrete probability distribution. Examples of things that can be modeled by categorical models would be things like image labels. So typically for all of these image classification networks, they output a softmax layer. Letters or words for our text generation networks, or musical notes in the case of the music networks that I'm interested in particularly. Or even things like robot commands, right? If you're working on a network in a kind of reinforcement learning environment, you might have a discrete set of commands: go forward, go left, go right, or change certain things. Things like moves in chess are also categorical, right? There's only a finite number of them. There's a set of possible moves, and that's can be modeled by this kind of categorical data. But not everything in the world is categorical. There's often data in the world which it has real values, not one of a number of categories. And in my case, I'm interested in music, so a lot of expressive data is continuous, or it's easier to express it as a real value rather than one of a number of categories. So things like controlling on a musical interface, or playing a musical instrument like a wind instrument where there's a lot of continuous variables happening at once. Things like piano sort of look categorical, right? There's only certain keys you can play at a certain time. But something like a wind instrument, everything becomes continuous, because if anyone who plays wind knows that you've got to change the pressure of your breath and the pressure of your mouth on the reed, and even like sort of half closing the keys on the saxophone makes different kinds of sounds. Little artistic things like drawing is also continuous. You're moving a pen continuously on a page, and it's easy to represent this as real valued numbers. There's other things that are continuous which aren't particularly expressive concepts as well. Things like biosignals, right? Like heart rate monitors, or ECGs, or electroencephalography, like the EEG graph on the right. That's brain scans of all the little electrodes stuck in a cap on your head, EEGs. And then in the bottom right, I've got a representation of voice, taking someone saying a word and then applying short-time Fourier transforms to create this, what we call a spectrogram, to see how a word is sort of mapped to different frequency bands as someone says it. So you could represent this as a sequence of continuous values, one continuous value for each frequency band. So in these cases, the kind of softmax layer categorical networks don't help us that much. We really need some kind of network which can model a continuous piece of data. Categorical versus continuous models. So for a little bit at the start of this lecture, I just want to talk a little bit about probability distributions in particular, and I'm not sure how much experience everybody in the room has. I imagine that some of you probably have taken a course in probability or done some work in mathematics, and you would have seen probability distributions. Others of you, maybe if you're mainly taken programming courses, you might not have seen probability distributions that much, and you might be a bit confused about what these things mean. So hopefully we can all get there together. So just discussing these things, these are ways of representing the chance of drawing some particular value in a real world situation. You've got some situation which is some random in some way, and you've got different chances of certain things happening. Maybe today it's sunny, tomorrow it's cloudy. There might be a certain chance of that happening, and you could model it using some kind of probability model. If you've got a categorical model, like this one on the left, ABC, then you've got your model consists of maybe a list of numbers that add to 1, right? 1 is the maximum probability. So each of your options should add to 1. So in this case, the chance of drawing A in this random situation is about 0.33, which is much higher than the chance of drawing B, which is only 0.2. You're only going to draw B 1 in 5 times. But if you're going to have a continuous case, we've got a different kind of model. I've got an image of one on the right, which is more like this kind of curvy function over the x-axis. So what this graph is telling us is that if you've got your chance of drawing maybe 8 is quite high, and your chance of drawing -5 is very low. Okay, you see how that works? On the x-axis, 8 is sort of at the peak of that curve up past 0.07, whereas -5 is very low. And this kind of function, or the picture of this function, is what's called a probability distribution function. And they're funny kind of functions, so they're really defined by the area under the curve rather than the curve itself. So the real interpretation of this is that if you have some region that you're interested in, say between 0 and 2, you could take the integral of this function and find the area under that curve, and that would give you the likelihood of drawing a sample in between 0 and 2. So they're a bit strange as functions go. I'll tell you more about them in a minute with specific examples. So here's our normal kind of continuous distribution. I say normal in two senses. It's the standard one, and also it's called that. It's called the normal distribution, the Gaussian distribution. Anyone seen this before in maths class? Yeah, there's heads nodding. Can anyone tell me how you define a Gaussian distribution? What are the parameters of a normal Gaussian distribution? There's two.
Mean and standard.
Mean and standard deviation. Got them in one. Yeah. So there's two parameters that are important for defining this function. Mean, which is normally called mu, and standard deviation, which is normally called sigma. And the mean is where the center of this graph is. So the mean of this one's 0. Standard deviation kind of gives us the width of this graph, right? So if you have a low standard deviation, then the normal distribution is going to be taller and pointier. And if you have a bigger standard deviation, it's going to be flatter. Normal distribution. Now, does anyone want to see the probability density function, or the PDF of the normal distribution? Here it is. It's fun. Ooh, look at that. Nasty stuff. It's got e's, it's got square roots. It's got a negative exponent. Oh man. So it's not the kind of thing that you sit down and enjoy, just the beauty of this function. Or maybe some people do, but I look at that and I'm like, oh, bad memories of maths classes. So a bit difficult to deal with, but we've got computers, so it's not that hard to manage these things. We can just make some code to do it. We will do that in a minute. So this function is usually called n, and that gives us the PDF of the normal distribution. And this is a function of x, and it's got two parameters, the mean and the standard deviation. Standard deviation is related to another function called variance by squaring it, so sigma squared is the variance. So it's often put this way, that you use sigma squared as the parameter, and that gives you that normal distribution. Now, we've got a problem. Normal distributions might not fit continuous data. So what if we've got some complicated distribution, right? It looks like this. these columns here, that's not going to be fit well by a normal distribution. I've actually got this in an IPython notebook, so I'm going to open that now. And it should be more fun to look at this in real time. Can everyone see? Hopefully this works. Cool, all right, here's our, well, I did it in Python already. It's not so bad once you type up the code, right? Just one line of code, that's not that complicated. That's the PDF for the normal distribution. And I just plotted it simply in Python. Now here's our mix of two different distributions, or complicated group of data. Now what I've done here, can you see what I did? I sampled from two different normal distributions, one centered on -5 and one centered on 5, and then I just put all of that data together. So this S1 is just a list of numbers, this S2 is another list of numbers, and then all S is a list of all of those numbers combined. And then I've done a histogram plot just to get an overview of how many values there are in here. Now, what I then do is fit a normal distribution to it. So I've calculated the mean of this this guy. The mean of all that data is going to be -0.03, and the standard deviation is 5. And then the normal distribution that matches those values doesn't match the data at all. That's terrible. So what are we going to do? Solution, mixture distributions. Has anyone ever seen this solution before in maths classes? Yeah, I know that the MDN guys have, but yeah, this is our solution. So a mixture distribution is a kind of probability distribution that lets us mix multiple different distributions together. So in our case, we're just going to consider mixtures of normal models, normal distributions, but you can actually use any old distribution, others are possible. I'm not a probability theorist, so I'm not going to get into that because I would be way outside my area of expertise. I know it works for these normal models though. So what you do for a mixture distribution is you suppose you've got k distributions, k components, and then you need the parameters for each of those component distributions. In the case of normal distributions, that's 1 mu and 1 sigma for each one. And then you don't just add these distributions together, you mix them with sort of relative weights. So some of these distributions might be more important than others. So we've got our weights here, which are going to be the pi's, pi I. And the important fact about the weights is that the weights have to sum to equal 1. Anyone feel this is ringing a bell? A sequence of numbers that sums to equal 1? Sounds like a categorical distribution, doesn't it? So we've got now we've got one distribution, the categorical distribution, for mixing all of our components, and then one distribution for each of these components to add together. And then we get the PDF, probability distribution function, of this mixture distribution defined as follows. The sum from I equals 1 to k of pi times the PDF of the normal distribution, or the particular normal distribution we're interested in. There should be a few i's in there as well. So that's not that complicated. It's just multiplying and adding numbers up together. So this is much easier than the normal distribution equation. So that is, the way you read this function is the likelihood of x occurring in this distribution is the sum of the weighted likelihoods for x for each normal model. Gaussian model is the same as normal model. So implementing this in Python, this is not too hard. I've got a function where I've got x, the value I want to draw. I'm testing to see its likelihood. I've got k, my number of distributions, a list of pi's, the weights, a list of mu's, all of the means, and a list of sigmas, all of my standard deviations. So I can just make a for loop and add up the value of pi multiplied by the normal PDF for each of those values, gives me my output. That's not too hard. Now going back to our data, we're going to plot the PDF of an evenly weighted mixture of the two sample normal models. Now I created that data set so I knew what the parameters of those models were, so I can do a very good job fitting it to a component 2 mixture distribution. So it means I've got k equals 2, I've got pi's 0.5 and 0.5, so they're the same. I've got my two means, -5 and +5. I've got my two sigmas, 2 and 3. and I used these components to create this distribution, and now I can plot it. So I'm doing a plot of x against the mixture of normals EDF function for those values. And that's much better, isn't it? So that is working for my small model. Okay. I'm going to go back to my talk. Okay. Told you about that bit. I've got extra stuff in these slides because they're online for you to look at later if you're interested. Yes, this solves our problem. So in this case, I knew all of these parameters because I had generated data, so I was sort of cheating a little bit. But normally, you'd have to learn these values somehow or optimize a set of parameters to fit your data properly. There's various procedures to do that. I think one is called kernel density estimation. Another one is expectation maximization optimization, which probably is used in KDE. So there's various procedures to do that for data, but in our case, we're not going to do any of those. We're going to do neural networks, right? That's the sort of universal optimizer we get to use for everything. Just apply deep learning to it, and it'll be fine. Yeah, so far, mixed distributions and normal distributions. That's the main thing that I'm asking you to have gotten so far. Are we on the same page? I'll check the Slido. Densities. Hi. How does this work? Hello. I'm going to start deleting some bad ones. Archive. Chat time archive. Perfect. Mix it up. I can't use threads. Good question. You did 9/11. Well, yeah, we love you, Charles. Thank you. Nice. Yeah, 2000 mini. Mixed densities. Nice. Cool. That one gets a upvote from me. How does this work? Yeah, okay, no. So I assume everyone's cool then. Good talk. Okay. Yeah. Now, mixed density networks. So, let's get all this stuff. So, neural networks can be used to model complicated real-valued data, right? And one approach you might want to do if you had real-valued data is, well, just have a single neuron at the output of your normal feed-forward neural network. That produces a real value, right? If you give it a linear activation function, the final neuron unit in your network would just output a number. So why can't we just train to that? Sure, you can do that. That's a totally valid way of training a neural network. You can do that for doing regression. People do that all the time. You would take your input value, your output value that's predicted by the network, and your output value that you know is to be true, and then you take the mean squared error of those two values, basically just measuring their distance, and that gives you your loss function for a neural network. But there was a problem with that in certain circumstances, which was brought up by Christopher Bishop in '94. There's a paper there cited in the references in these slides. And he showed that basically when you do that, you're asking your neural network to fit a single normal model, just like we had our problem before. And if you've got a problem to solve, a regression problem, where, for instance, there's two valid values that are far away in the output space, then your neural network is sort of going to head for the mean all the time. Right? Now, I don't have a good diagram here, so I'm just going to draw one, but the kind of problem I'm thinking of is maybe your input value is X, right, and your output value is Y, and you're trying to model some data, right? I'm just putting my data here as just a bunch of dots, okay? That's looks like some kind of function, right? You could probably model it with a polynomial if you wanted to. And your neural network, using mean squared error and a standard neuron output at this particular value, x0, is going to try to fit that to a normal model, right? Sort of putting a normal model in the third dimension, sticking out of the wall. Okay, that's all fine, but if your data looks like this, you've got two modes in it, splits into two parts, well, it's not going to match that model. It's actually going to try to put one in the middle, right, a very flat model. Well, that's not going to solve our problem very well, is it? And I'll give you an example of that not working in a minute. So the solution that Bishop, as Bishop put it, in 1994, so it's not like this is new, was to use mixture density networks. So the idea here is that instead of directly predicting the value for y, you predict the values of the parameters of a mixture model that you could then sample to get y. So rather than predicting y, you predict a bunch of pi's, a bunch of mu's, and a bunch of sigmas, and then you get some mixture density model for each of these values. That would be good, right? Because then we could have two normal distributions here, one for this part and another one for this part. Right? That might solve our problem a lot more effectively. Yeah, oops. Rather than mean-squared error for training, use the PDF of the mixture model. Now there's goods and bads here, right? The good is that this